The torque acting on a current carrying coil is given by tau is equal to m cross B, where m is the magnetic moment of the current carrying coil and B is the external magnetic field, which is equal to mb sine theta. Theta is the angle between the m vector and the b vector. Now the torque is going to be minimum when theta is 0, so that sine theta is 0 and torque is 0, and it is going to be maximum when theta is equal to 90 degrees, because in that case sine theta is 1 and torque is equal to mb. Just a little bit of explanation on this. If you have a current carrying coil, say this is a current carrying coil which is placed in an external magnetic field. Say this is the north and the south pole. So this, you have a magnetic field in this direction, and say this coil is carrying current in this direction, in the anti-clockwise direction. So the direction of the dipole moment m is equal to current times area, and the direction of the dipole moment is given by the right hand rule. So you have to curl your fingers. You curl your fingers in this direction, and then your thumb points inwards into the page. So this is the direction of the dipole moment m, which is into the plane of the page. So in this case, the angle between the dipole moment and the magnetic field is going to be 90 degrees. See, the magnetic field was like this, and the dipole moment is into the plane of the board in this case. So the angle over here is going to be 90 degrees. And suppose you have a coil which is placed like this. Say the coil is placed like this, and this is the north and the south direction, the north and the south pole of a magnet. This is the direction of the magnetic field, and say current is flowing in this direction. Now you curl your fingers along this. So if you curl your fingers along this, your thumb will point outward in this direction. So this is the direction of the magnetic dipole moment, this is the direction of the magnetic field, and here theta is this angle between the dipole moment and the magnetic field.